Welcome. In this video we will try to derive the expression for magnetic field at the center of a current carrying loop. Now we're going to use the biot-savart law, which states that the magnetic field due to a small element dl is dB. Now dB is directly proportional to the length of the conductor, the current flowing through it, and inversely proportional to the distance between the point where we want to measure the magnetic field and dl. This is the unit vector r, right, and it gives the direction from dl to the point, right. So this is unit vector r, and then mu naught over 4 pi is the constant of proportionality, where mu naught is permeability. Alright, so let's see how we can find the expression. Now there are two different forms of this equation which are pretty much the same. If you express the unit vector as the vector over the magnitude of vector and you substitute this in this equation, you will get dl cross vector r over 4 pi r cubed, and then the rest of the expressions remain same. So both these equations will be the same thing, so don't get confused. Now let's see how we can find it. If we use this expression and we integrate it for this circle, right, so if dl is this small length of the conductor, and if we integrate it over the entire circle, we'll get the expression that we want. So integral of dB is just b, should be equal to integral of mu naught I over 4 pi dl cross unit vector r over r squared, right. And then what is mu naught I over 4 pi? We know that mu naught over 4 pi is a constant. Also we will assume that it remains constant for the circuit, so we'll get b is equal to mu naught I over 4 pi. Since we do not integrate constants, it can come out of the integral symbol, right. And then what remains? Dl cross r, which I can write as dl, since r is a unit vector, I will later substitute it as 1 sine theta over r squared. Now what is r squared? R will also remain constant. Since it is the radius, it doesn't matter where I take the radius, it will remain constant. So I can even take r squared as out of the integral symbol. So what I get now is b is equal to mu naught I over 4 pi r squared integral of dl, right. And then r is just 1, so I'm not going to write it. And then what is sine theta? Let's see what is theta. So theta is the angle, this angle. What is the direction of dl? It is this way. So we can say that the direction of dl is the same as the tangent to the circle at this point, right. So at any point it will be tangent. And what is the angle between a radius and a tangent? It's 90 degrees. So theta is 90 and sine of 90 is 1. So I'm not going to write sine 90 as well, because it's just 1, and 1 multiplied by dl is just dl. So what is now integral of dl? So we know that we are trying to integrate dl over this entire circumference. So integral of dl is just the circumference of a circle. And what is the circumference of a circle? It's just 2 pi r. So we can say b is equal to mu naught I over 4 pi r square, and multiplied by integral of dl is 2 pi r. So let's see what we get. What we are left with is just mu naught I over 2 times